Hi, today we'll continue our discussion on inheritance, and we'll look at the notes. Class hierarchies. A child class derived from one parent can be the parent of its own child class. Multiple classes can also be derived from a single parent. Thus, inheritance relationships can develop into class hierarchies. There is no limit to the number of children a class can have or to the number of levels to which a class hierarchy can extend. Two children of the same parent are called siblings. Although siblings share the characteristics passed on by their common parent, they are not related by inheritance because one is not used to derive the other. In a class hierarchy, common features should be kept as high up in the hierarchy as possible. This helps the theory of software reuse and is a relationship. So classes should develop an is-a relationship between the child and the parent class. So the child is a relation, for example, if we have a vehicle class and a car is a vehicle. So the car is a vehicle. So the child is a car and the vehicle is a parent. An inherited feature might have originated in the immediate parent, or possibly several levels higher in an ancestor class. Ancestor class is a class that is a parent of the child's parent class or higher. Grandparent or great-grandparent, which are called ancestor classes. The object class. In Java, all classes are derived from the object class. If a class definition doesn't use the extends clause explicitly to derive itself from another class, then that class is automatically derived from the object class by default. Example, class thing with whatever code inside is equivalent to class thing extends object with whatever code. Because all classes are derived from object, all public methods of object are inherited by every Java class. They can be invoked through any object created in any Java program. The object class is defined in the java.lang package of the Java standard class library. The toString method is defined in the object class, so the toString method can be called on any object and be overridden. When a printline method is called with an object parameter, toString is called to determine what to print. When we define a toString method in a class, we're actually overriding an inherited definition. The definition for toString that is provided by the object class returns a string containing the object's class name followed by a numeric value that is unique for that object. Usually, we override the object's version of toString to fit our own needs. The string class has overridden the toString method so that it returns its stored string value. We are also overriding an inherited method when we define an equals method for a class. The purpose of the equals method is to determine whether two objects are equal. The definition of the equals method provided by the object class returns true if the two object references actually refer to the definition of the equals method provided by the object class returns true if the two object references actually refer to the same object, if there are aliases. Classes often override the inherited definition of the equals method in favor of a more appropriate definition. For example, the string class overrides equals so that it returns true only if both strings contain the same characters in the same order. So some of the methods of the object class: Boolean equals, which takes an object, obj, any object parameter. In this case we called it obj. It returns true if this object is an alias of the specified object. String to string returns a string representation of this object. Object clone creates and returns a copy of this object. I'm going to assume that you know this stuff, but in future videos we will discuss more of the basic theories of Java. Abstract classes. An abstract class represents a generic concept in a class hierarchy. As the name implies, an abstract class represents an abstract entity that is usually insufficiently defined to be useful by itself. An abstract class may contain a partial description that is inherited by all of its descendants in the class hierarchy. An abstract class is just like any other class, except that it may have some methods that have not been defined yet. Its children, which are more specific, fill in the gaps. An abstract class can be instantiated and usually contains one or more abstract methods which have no definition. There is no body of code defined for an abstract method, and therefore it cannot be invoked. An abstract class might also contain methods that are not abstract, meaning that the method definition is provided as usual, and an abstract class can contain data declarations as usual. A class is declared as abstract by including the abstract modifier in the class header. Any class that contains one or more abstract methods must be declared as abstract. In abstract classes, the abstract modifier must be applied to each abstract method. A class declared as abstract does not have to contain abstract methods, however. In UML diagrams, the names of abstract classes are shown in italics. Consider a vehicle class. A vehicle class could be defined at the top of the hierarchy. Concepts that apply to all vehicles can be represented in the vehicle class. Vehicles such as car, boat, and airplane. In this way, the vehicles don't have to define the same concepts redundantly. This can also save time in large software developments. We could declare a variable called speed in the vehicle class, and all specific vehicles in the child class will inherit the variable speed. Similarly, in vehicles, we could declare an abstract method called fuel consumption. Implementation of this method is left up to each subclass to make each class unique from the other, as fuel consumption will be different in car than in truck, than in boat or plane or motorcycle. Some concepts then don't apply to all vehicles, such as the num wheels variable. Some concepts don't apply to all vehicles, such as the num wheels variable, because not all vehicles have wheels. The child class that has wheels can add this variable as a normal non-abstract variable at the appropriate level in this hierarchy. There are no restrictions on where in a class hierarchy an abstract class can be defined. Usually, abstract classes are located at the upper levels of a class hierarchy. It is possible to derive an abstract class from a non-abstract parent. Usually, a child of an abstract class will provide a specific definition for an abstract method inherited from its parent. Specific case of method overriding. Giving a new definition from the one its parent provides. If a child of an abstract class does not give a definition for every abstract method that inherits from its parent, then that child is also considered abstract. Side note, don't use final or static to declare abstract methods, because a final method can be overridden in subclasses. An abstract final method would have no way of being given a definition in subclasses. A static method can be invoked using the class name without declaring an object of the class, because abstract methods have no implementation. An abstract static method would make no sense.